So what if I told you that you, me, and every living thing are all just temporary vehicles for something practically immortal? That is the wild and often misunderstood idea at the heart of Richard Dawkins' The Selfish Gene. This is a book that didn't just explain evolution. It flipped our entire understanding of it upside down. And right at the center of it all is this one massive puzzle. If evolution is all about survival of the fittest, nature red in tooth and claw, then why in the world do we see things like self-sacrifice? Why does something like altruism even exist? It just doesn't seem to add up. Now, for Dawkins, this wasn't some dry academic problem. Not at all. He saw it as a whodunit, a genuine mystery. He actually wrote, "Biology ought to seem as exciting as a mystery story, for a mystery story is exactly what biology is. So let's put on our detective hats and follow the clues he laid out."
Okay, first things first. We need to investigate the scene of the crime, which is really the mystery of altruism itself.
And our star witness? The worker bee. This bee performs the ultimate act of sacrifice. It stings an intruder to protect the colony's honey, but in doing so, it rips out its own insides and dies. It's a literal kamikaze mission. I mean, that act completely defies the logic of individual survival. So here's the question. How could a gene that programs its carrier to commit suicide possibly get passed on to the next generation? To solve this, we have to stop looking at the bee and start looking somewhere else entirely. And this leads us to our prime suspect, a totally radical shift in perspective that Dawkins calls the gene's eye view. Okay, this is the absolute core of the whole argument. Dawkins says, forget about the species, forget about the individual organism for a second. The real main character of the story of evolution is the gene. And it's really important to understand what he means by selfish. He doesn't mean genes have motives or feelings. It just means they behave as if their only goal is to make more copies of themselves. That's the whole game. And this is a point Dawkins makes over and over again. He's describing how things are, not how they ought to be. This is not a moral blueprint. He's basically warning us, look, if you want to build a generous and cooperative society, don't expect biology to just do all the heavy lifting for you. So where do we fit into all this? Well, in this view, we're what he calls survival machines. You can think of us and every other living thing as these incredibly complex robots built by our genes for our genes. Our bodies are the vehicles they use to stay safe and navigate the world, all in the service of making more copies. Okay, so we've got our theory, we've got our new perspective. Now let's take it back to the evidence and see if we can finally crack the case of the selfless bee. The first big clue comes down to a very simple fraction, 1/2. That's the probability that you share any single gene with a full sibling or with one of your parents or children. So, from a gene's perspective, a gene that programs you to help your brother has a 50% chance of helping an exact copy of itself living inside your brother. This is the whole idea behind kin selection. And suddenly, the worker bee's suicide makes perfect, logical sense. She isn't just dying for the colony. Her genes are playing a numbers game, sacrificing their one vehicle to ensure the survival of countless identical copies inside her relatives, especially the queen. But hey, altruism isn't just a family affair, right? It can also pop up between total strangers. This is where reciprocal altruism comes into play. The logic is as simple as it sounds. You scratch my back and I'll scratch yours. One person does something helpful at a small cost, expecting that the favor will be paid back later on. In the long run, both individuals and their sets of genes come out ahead. What's so amazing about this gene-centered view is that it doesn't just explain altruism, it gives us a powerful new lens to understand all kinds of social behaviors, from conflict to cooperation. It's like we found the replicator's secret playbook. A key idea here is something called an evolutionarily stable strategy, or an ESS. The easiest way to think about it is as a behavioral rulebook. And if most of the population follows that rulebook, no alternative strategy can do any better. It's stable because it's immune to being cheated from the inside. To see how this works, let's use a classic model. Imagine a population with two kinds of strategies for dealing with a fight. You've got your hawks, who always fight as hard as possible and only retreat when they're seriously hurt. And then you have your doves, who just do a lot of posturing and threatening, but always back down if things escalate. So, which is the winning strategy? Well, what happens is that neither pure strategy really works. A population of all doves is a paradise for a single ruthless hawk. He'd win every single time. But a population of all hawks is a bloodbath. They're constantly fighting and getting injured, which is bad for everyone. It turns out the only evolutionarily stable state is a specific mix of both hawks and doves in the population. So, all this is great for understanding animals, but what about us? Are we humans just pre-programmed robots too? Well, this is where the final part of the book delivers a really radical twist. This is where Dawkins introduces a second kind of replicator, and this one isn't made of DNA. He called it the meme. Now, I know what you're thinking, but he's not talking about cat pictures. For Dawkins, a meme is any unit of cultural transmission. It's an idea that spreads. Memes can be anything. A tune you can't get out of your head, a new catchphrase, fashion trends, a specific way of making pottery, even incredibly complex ideas like justice or democracy. It's any bit of culture that can be imitated and passed from one brain to another. And just like genes compete to survive in the gene pool, memes are in a constant battle for survival in the meme pool of our culture. They hop from brain to brain through imitation, and the most successful ones, the catchiest, the most useful, the most compelling, are the ones that spread. The others just fade out. It's a whole second type of evolution, and it moves at lightning speed. And our capacity for this kind of cultural evolution gives humanity a unique power. This leads to the book's most powerful and hopeful message. Dawkins says, let us understand what our own selfish genes are up to, because we may then at least have the chance to upset their designs, something that no other species has ever aspired to. Think about that. In a world full of survival machines, we're the only ones who can actually become aware of our own programming and rebel against it. And that leaves us with the ultimate question, doesn't it? If our bodies are just survival machines built by our genes, and our minds are this fertile ground for self-replicating ideas, or memes, are we ever truly in control? Who's really in the driver's seat?